No.
Yeah, your line.
Okay, children, sorry for the interruption. There was some technical issue. Okay, that's why. Okay. So first, we have to draw a rough sketch. What I have just shown exactly in the graph. So what we have to draw. So parabola is right side open. Okay. The given point is somewhere 1, 4. You mark it as 1, comma 4, and let it be A also. Okay. The given point 1, 4, that can be taken as A. And we have to find on a point on this parabola such that the distance is minimum. Okay. So we don't know what is that point actually. That is our target actually. We have to find the point on this parabola. And equation of parabola is given y square is equal to 2x. Clear? So we have to draw a rough sketch of the given situation like this. Okay. Now the required point, you can take it as some xy or some hk. Generally, we can take as hk, or you can take xy also, no problem. Okay. So our target is to find the coordinates of the point B, that is h comma k. So we have to start like that. Okay. Let capital A 1, 4. Just wait for a minute. Okay.
Yes, sir. Keep it going.
Again, sorry for the interruptions. Okay, there was some net issue and technical issue. Okay, that has been resolved by the technical people. Okay, actually, I don't know whether uh, you heard from the beginning what I have taught. Actually, what I have taken to. So once again, I will tell you. So I have started this problem yesterday. Somebody has posted this question in the chat box to get give the solution. Okay, so this is the question actually. Find the uh, distance of the point 1, 4. The minimum distance of the point 1, 4 from the parabola y square is equal to 2x. Okay, a point is given 1, 4, and the parabola is given y square equal to 2x. So you have to find the minimum distance of the point 1, 4 from the parabola. So this is the problem I am going to discuss. Okay, I think there was some technical issue, and some of you might not heard my beginning actually. Clear? So draw a rough sketch of the situation. Parabola, right side open parabola. A given point is 1, 4. So we have to find the distance AB. Okay. So that, sorry, the point B, the coordinates of the point B, such that the distance AB is minimum. Okay, the distance AB must be minimum. Clear? So actually, exactly, if I plot the parabola and plot the point, the situation is like this. Once again, I am showing because there was some problem in the beginning. Okay, the given point is 1, 4. Parabola is right side open. So we have to find a point on the parabola such that the distance of AB, the distance AB is minimum. Okay, the point can be anywhere on the parabola, but when the distance is minimum, that is our question actually. Okay, if you draw the graph exactly, and sometimes we may be able to get the answer by looking the graph also. Okay, somewhere it may be near to 2, 2 maybe. Okay, we will see exactly. Algebraically, we will find it exactly where what must be the coordinates of the point B. Okay, so roughly sketch the figure, and A be the given point, and capital B, let us take it as capital B, HK be the required point, on the parabola. Okay, required point on the parabola. What is the parabola equation? You know, y square is equal to 2x. Then we have to find the distance AB. Okay, therefore, the distance AB, let us take it as D, capital D. The distance D is equal to, you know the distance formula, root of h minus 1 the whole square plus k minus 4 the whole square. Okay, distance formula, h minus 1 root of h minus 1 whole square plus k minus 4 whole square. Clear? Okay, now to avoid the root for differentiation purpose, it is better to remove the root. Yesterday also we have done the same technique. So let us take the square of d, that is d square. So d square is equal to h minus 1 the whole square plus k minus 4 the whole square. Okay, whenever d is maximum or minimum, d square is also maximum or minimum. Okay, so we square it, and this square can be again denoted by some other symbol, some s or any new symbol you can put. Okay, now we have to differentiate this function. You can see that there are two variables, h and k actually. Okay, so we have to convert in one variable. For that, we use the equation of the parabola. Okay, hk is a point on the given parabola. Hk is a point on the parabola, means it must satisfy that equation. H comma k satisfy the equation, means k square is equal to 2h. In place of x, you put h, and in place of y, you put a k. Okay, hk must satisfy this equation of the parabola. So that means k square is equal to 2h, or h is equal to k square by 2. Okay, h is equal to k square by 2. So that we have to substitute here. So that is equal to, that is s, yeah, d square is equal to, in place of h, we put k square by 2 minus 1 whole square plus k minus 4 the whole square. This is our s. Okay, s is same as d square. Now this is a function in one variable. The variable is k. So usually what we have to do to find the maxima and minima, we have to differentiate with respect to k. The variable is k actually. So find ds by dk. Find ds by dk. Everybody can write the derivative. So ds by dk is equal to 2 times k square by 2 minus 1. Derivative of x square means 2x. So chain rule we have to apply. Okay. 2 into k square by 2 minus 1 into inside the bracket there is k square by 2. So derivative of that means 2k by 2 or k only. Chain rule. Okay. First apply the derivative of x square, that is 2x. Then derivative of k square by 2 minus 1, that is 2k by 2, that is k only. Plus derivative of k minus 4 whole square means 2 into k minus 4. 2 into k minus 4. So again simplify it further. Okay. Multiply 2 inside the bracket. Multiply by k also. So k cube. Okay. K cube minus 2k minus 2k plus 2k minus 8. And that is equal to minus 2k plus 2k cancel. So what you will get is k cube minus 8, isn't it? K cube minus 8. So this is our first derivative. Okay. Again, we need the second derivative also. So what is the second derivative? At the same time, we can calculate second derivative, that is 3k square. Isn't it? Second derivative is 3k square. Now very clearly, from here itself, you can see that this value is positive only. Whatever you put for k, the 3k square will be always positive only. You know? So from here itself, we can confirm. What is the confirmation? Second derivative is negative means s must be minimum only. No, s must be minimum. Where it is minimum, that we will get from the first derivative. Okay, critical point. Second derivative is positive means s must be minimum only. S must be minimum. Okay, when s is minimum, that is obtained from the first derivative. Okay, maximum or minimum is always occurring at the critical point. Okay, critical point means what here? How to get when ds by dk equals 0. ds by dk is 0 means k cube minus 8 equal to 0. K cube minus 8 equal to 0 means k is equal to 8. Sorry, k is equal to 2. Okay. Generally, we first find the critical point. Okay, then after that we will substitute in the second derivative. Then we will see the sign actually. Okay, but from second derivative is then the value is 3k square. So from there itself, it is confirmed that it is positive. Whatever you put for k, it is always positive. That's why there itself we have written s is minimum only, and minimum is obtained when the first derivative is equal to 0. Critical point is k is equal to 2. Okay, that means s is minimum when k is equal to 2. Okay, clear? S is minimum when k is equal to 2. So we have got the value of k. Now what is remaining? H. Okay. So how to get h? We know the relation between h and k. hk satisfies the parabola. hk satisfies the parabola h comma k. The parabola equation is y square is equal to 2x. Y square is equal to 2x. So we know k square is equal to 2h. K square is equal to 2h. We have already done earlier also. So therefore, k is 2. That means 2 square. So 4 is equal to 2h. 4 is equal to 2h. Therefore, what is h? H is equal to 4 by 2, and that's equal to 2. Isn't it? H is equal to 2. So k is equal to 2, and h is also equal to 2. Okay. So the required point is h comma k. Hk. That means 2 comma 2. Therefore, yes, S means actually d square. Remember, the distance square we have taken. S equal to d square is minimum when you are at the point 1, 2. Sorry, 2, 2. The point is 2 comma 2. Okay. That means d is also minimum. Okay. At the same point only, d is also minimum. Therefore, d is minimum when the point is 2 comma 2. This is the required point on the parabola. Okay. If you want the distance, we can calculate using the distance formula. Distance formula apply and get the value of the minimum distance. If the question is to find the minimum distance, also find the minimum distance. Okay. I think it is clear. So that we can clearly observe if you plot the point graph exactly. Okay. But always it is not possible. Okay. But just I am showing what we have got algebraically will be correct only. From the graph also you can see that this is the point actually. Okay. Here f represent the distance actually. Distance from A and B. And the value you can see in the left side of this graph actually that is 2.24 at this point. When B is 2 comma 2, the value of the distance, the minimum distance is 2.24. If I move this point again, the distance has increased 2.32. Clearly, the distance will increase only. Okay. If I move from 2 to also, again you can see the distance is increasing. But when the point is exactly at 2 comma 2, the distance will be given as the distance is exactly 2.24, the actual distance. Okay. Okay. Now let us take some more problems from this application. Hope that this question is clear to you. The sum of the perimeters of a circle and a square is k. The sum of the perimeters of a circle and a square is k, where k is a constant. Where k is a constant. Prove that. Prove that the sum of their areas is minimum. Sum of their areas is minimum if the side of the square is double the radius of the circle. If the side of the square is double the radius of the circle. So please take this problem, okay? Sum of the perimeters of a circle and a square is k, where k is a constant. And prove that the sum of their areas is minimum if the side of the square is double the radius of the circle. Side of the square is equal to double the radius of the circle. Okay. What is given? The perimeter, sum of the perimeters of a circle and a square. That is a constant, a k, a constant. Okay. So first, let us draw a rough figure. A circle and a square. Okay. A circle and a square. Let us take the radius of the circle as r and the side of the square as a. R be the radius of the circle. Let R be the radius of the circle and A be the side of the square. Okay. You have to start like that. Let R be the radius of the given circle and A be the side of the square. Then what is given? Sum of their perimeters. Sum of their perimeters is a constant. Okay. So given that the perimeter of the circle, everybody knows what is the perimeter of the circle. That is 2 pi r. 2 pi r. And perimeter of the square, that is 4 times a, 4a. And that is given a constant equal to k. 2 pi r plus 4a is equal to k. Where k is a constant, remember. K is a constant. You can name it as some equation 1. Okay. We have to use this equation later. Now we have to find the area, combined area as a function. Okay. So let the combined area let it be a, capital A. Combined area means area of the circle. Area of the circle, you know, pi r square. Area of the square, we know what is the area of the square. That is side square, that is a square. Okay. The combined area, that is pi r square plus a square. So what we have to do actually, what we have to show here, this area is minimum when the side of the square is equal to the double of the radius of the circle. That means we have to show that A is equal to 2r. Remember, A is equal to 2r when this area is minimum. So for that, we have to differentiate. Okay, but before that, you can see that there are two variables, r and a. So we have to convert in one variable. For that, what is given? 2 pi r plus 4a is a constant. 2 pi r plus 4a equal to k. From the first equation, we can get either r or a. One of them we can change. Okay, that is up to you. If you want, we can change r. Otherwise, we can change a. Doesn't matter. So, I will change a. Okay, so pi r square plus. What is a from this equation? 4a is k minus 2 pi r. Okay, 4a is equal to k minus 2 pi r. So, a means k minus 2 pi r divided by 4 whole square. Okay, a is equal to k minus 2 pi r divided by 4 whole square. Now you can see everything is converted into one variable. The variable is r. Remember, the variable is r only. So you can differentiate also now directly. Some modification, if you want, you can do it. You can square it actually. Okay. So that is equal to pi r square plus k minus 2 pi r whole square divided by 16. This is our a. Now it is in one variable. You can proceed with the differentiation. Okay. Every time for maxima, minima, we have to do two things. First derivative, then second derivative, then critical point, then find the sign of the second derivative. Okay. So what is dA by dr here? Derivative of pi into r square means pi into 2r. That is 2 pi r. 2 pi r plus 1 by 16 is a constant. 1 by 16 into derivative of k minus 2 pi r the whole square. That is 2 into k minus 2 pi r chain rule. We have to apply the chain rule. Okay. 2 into k minus 2 pi r not completed into we have to multiply the derivative of the term inside the bracket. Okay. What is inside? What is inside the bracket? 2 minus k minus 2 pi r. But k is a constant. So 0. Derivative of minus 2 pi r means minus 2 pi. You should be very, very careful while differentiating. Okay. Sometimes we may commit here some mistake. Then everything will go wrong. Okay. So derivative of k minus 2 pi r whole square means 2 times k minus 2 pi r into derivative of k minus 2 pi r. Derivative of k minus 2 pi r is minus 2 pi. Now the differentiation is over. Okay. First derivative is over. We can modify. Little simplification is needed. So do it. That's equal to 2 pi r. No change. Then second term. 2 into 2, 4. Okay. Actually, minus is also there. And divided by 16. So that means 1 minus 1 by 4. Minus 1 by 4 into k minus 2 pi r into 1 pi is also there. That also can be written in the beginning. Okay. Minus 1 by 4. Yeah, minus pi by 4 into k minus 2 pi r. Okay. Let us do the second derivative also at the same time. So what is d square a by d r square? Second derivative. Again differentiate. D square a by d r square. That means derivative of 2 pi r. With respect to r means derivative is 2 pi. 2 pi minus pi by 4 is a constant. Pi by 4 into derivative of k minus 2 pi r. Derivative of k is 0. Derivative of minus 2 pi r is minus 2 pi. Okay. So that is equal to 2 pi minus into minus is plus actually. Minus into minus is plus. Then pi square. Okay. Pi square divided by 2. And you can see that d square a by dr square is free from any variable actually. There is no r actually. And very clearly this value is positive only. 2 pi is positive, pi square by 2 is positive. That means everything is positive only. So from here itself, directly again we are getting the second derivative is positive, always positive. That means a must be minimum only. Okay, a must be minimum. A must be minimum. But where it is minimum, when it is minimum, that we have to find. The critical point is remaining. Okay. When A will be minimum at the point where the first derivative is 0. Okay. Maximum or minimum is always obtained by equating the first derivative equal to 0. The critical point is always obtained from the first derivative. Equating first derivative is equal to 0. So what is the first derivative? 2 pi r 2 pi r minus pi by 4 into k minus 2 pi r equal to 0. Isn't it? 2 pi r minus pi by 4 into k minus 2 pi r. That's equal to 0. So we have to obtain the value from here. Okay, what happens from here? So that is 2 pi r equal to pi by 4 into k minus 2 pi r. 2 pi r equal to pi by 4 into k minus 2 pi r, isn't it? Okay. Now you see the given condition. Okay, some simplification you can do very easily if you go to the first equation. If you apply the first condition, what is given? 2 pi r plus 4a is k. So what is k minus 2 pi r? K minus 2 pi r is 4a. Okay, k minus 2 pi r is 4a. So in place of k minus 2 pi r, we can write 4a. Okay, from the first equation. So 2 pi r is equal to pi by 4 into 4a. Okay, in bracket, you write the given condition. The beginning, what we have written is 2 pi r plus 4a is k. That means k minus 2 pi r is equal to 4a. So again simplify. Therefore, 2 pi r equal to 2 pi r is equal to 4 pi into a. Yeah, a into pi. 4 and 4 will cancel. Okay. And both sides we can see pi. Pi is common. So pi also can be cancelled. Pi also can be cancelled. No? So what is remaining? 2r is equal to a. So we have received at the answer. Okay. When the area is minimum, directly we got the answer. Okay. When the area is minimum, what is the value of a? A is equal to 2r. That is, the side of the square is equal to double the radius of the circle. So hope that it is clear to all of you. And you can watch this video at a later time also. Okay. It will be recorded and available. Okay. Always it is available. So if something is missing, some step is missing when you're writing, you can see later. Okay. Okay, let me see the chat box. I think some questions are there. Let me see. Show that semi-vertical angle of a right circular cone of given surface area and maximum value is sine inverse 1 by 3. Can you explain this, sir? That is I think it is a textbook problem only. For the curve, next question. For the curve, y is equal to 4x cube minus 2x power 5. Find all the points on the curve at which the tangent passes through the origin. I think that is a deleted question actually. Okay, tangent and normal. Tangent and normals are not in the syllabus, so no need of doing that question actually. So this is the textbook problem. So I don't think it is, because we have some constraint, time constraint actually. Okay. So instead of doing the same problem, textbook problem, let us do some other problem. So take this question. If the sum of the lengths of the hypotenuse and a side of a triangle, right triangle, is given, show that the area of the triangle is maximum when the angle between them is pi by 3. If the sum of the length of the hypotenuse and a side of a right triangle is given, show that the area of the triangle is maximum when the angle between them is pi by 3. So the question is like this. We have given a right angle triangle. Let the triangle be ABC. Okay, right triangle, let us take it as B. But what is given? The sum of the lengths of the hypotenuse and a side is given. Given means is a constant. That's the meaning. Okay. The hypotenuse, let it be H. And one side, either AB or BC. Okay, let it be A is given. Okay, this side is given. BC is given. Let it be A, small a. So what is given actually? H plus A is a constant. Okay, sum of the length of the hypotenuse and a side means H plus A is a constant. Then show that area of the triangle is maximum when the angle between them is pi by 3. So we have to show that this angle is pi by 3 when at the time the area of the triangle is maximum. Okay. So please understand the question actually. Okay. So what is given here? The hypotenuse and another side, the total is fixed. Okay. Total is fixed. So we can make so many triangles by varying. Okay. Some fixed number is given. Okay. Suppose the fixed number is some 10. For example, I am telling. Okay. 10. So if you make some triangle, if you make a right angle triangle with some values for H, okay, 6, and the other side is then 4. Okay, like that you make so many triangles. So when the area is maximum, we have to prove that the angle between them must be pi by 3. For the time being, let the angle between the two sides, means hypotenuse and the given side, be theta. That is, we have to find out actually. Okay. Okay, anyway. So draw a figure, mark the hypotenuse as H and another side as A. Okay. BC, you can mark it as A. Generally, we mark the side angle, so the side opposite to the angle A as A. That's why I have taken A. Or B, anything you can mark. So what is given here? Given that H plus A is a constant. Constant, you can take it as K. Some fixed number. Okay, H plus K is fixed. H plus K may be 20 centimeter. H plus K may be 15 centimeter. Some fixed number. H plus A is a constant. Okay, H plus A. Now we have to find the area. We have to maximize the area. Okay. So area means, you know, the area formula, half into base into height, half into base into height. Okay, so we need the third side actually. So very clearly, very easily, you can give the third side. Hypotenuse is h and one side is a, means the remaining. The third side will be what? Using Pythagoras theorem, the remaining side must be root of h square minus s square. Very clearly, very easily, directly we can write Pythagoras theorem by Pythagoras theorem. Okay. Therefore, what is the area of this triangle? What is the area of the triangle? Half into base into height. So what is base? A. The other side is then root of h square minus s square. So half into a into root of h square minus s square. Okay, here also you can see a root here. Na? Whenever a root comes in this type of problems, there will be little difficulty in differentiating while differentiating. Na? So to avoid that problem, we always do, we will take the square of that. So in place of a, I will take a square. Okay, s square equal to 1 by 4 s square. Yeah, s square divided by 4 into h square minus s square. If you take the square also, there won't be any change in the value of the critical point. Okay, whenever a is maximum, s square is also maximum. Now, okay, this is a function that contains two variables, h and a. Okay, h and a both are variables actually. It is not fixed numbers. So we have to convert in one variable. We have to convert in one variable. For that, what to do? This h square minus s square can be factorized. Okay, using algebraic identity, s square minus b square equal to a plus b into a minus b. So h plus a into h minus a, h plus a into h minus a. Now we know h plus a is k. H plus a is given as a constant. So directly we can substitute h plus a is equal to k into h minus a. H minus a we have to replace. Okay, how to do that one? Again, use the same condition. H plus a is equal to a constant. H plus a is a constant. That means h is equal to k minus a. So h minus a is equal to k minus a minus a, k minus 2a. So h minus a is equal to k minus 2a. H plus a is directly k. Okay. H minus a. H minus a, we can write h is k minus a. So h minus a means k minus a minus a. That is k minus 2a. Now you can see this is a function in one variable only. What is the variable? The variable is a. K is a constant. Okay. 4 is a constant. So a is the variable. So we have to differentiate. We have to differentiate. Okay. So let this can be taken as some z for derivative purpose. I rename this s square as some z. Okay. So that we can write dz by dA like that. So differentiate it. dz by dA. dz by dA. Okay. So if you want, you can, before the differentiation, we can do some more modification to avoid the product rule. Okay. Otherwise, we have to apply the product rule. So better to take s square inside. S square take inside. That means ks square minus 2a raised to 4. So that we can avoid the problem of product rule. Okay, directly we can differentiate. Okay, so what is the dz by dA? That's equal to k by 4 into k into derivative of a square is 2a. So 2ka minus 8a cube. 8a cube. Normal basic differentiation. And that is equal to if you want little modification you can do. You can take the 2 outside. Okay, 2 is common. Remaining you keep it like that only. You take 2 outside, so you will get k by 2 into ka minus 4a cube. Okay. Okay, let us find the second derivative also. What is the second derivative? D square z by dA square. So k by 2 into derivative of ka means k minus 12 s square. Derivative of a cube is 3s square. So this is the second derivative. Okay. Now from here, it is not so direct to say that whether it is positive or negative, just like in the previous cases. Okay. So we have to wait. So what we have to do? We have to find the critical point. So dz by dA is already ready. Second derivative is already ready. Now find the critical point. Let us find the critical point. Okay. Suppose the first derivative is 0. Critical point is always obtained from the first derivative. First derivative is 0 means the first equation. The first equation is what? K by 2 into, which implies, therefore, k by 2 into ka minus 4a cube is 0. K by 2 is a constant, so there is no need of writing. So ka minus 4a cube must be 0. Okay. K by 2 into ka minus 4a cube must be 0, or ka minus 4a cube must be equal to 0. So therefore, what is the next step? Take a outside. Okay, a into k minus 4a square equal to 0. That means a is the side actually. A is the side of the triangle. It cannot be 0 actually. So only possibility is the second term must be 0. Okay, second term 0 means k must be equal to 4a square. A is side actually. Side cannot be 0. So k must be equal to 4a square. K must be equal to 4a square. Or you can write root k is equal to 2a. That is not necessary, but we can write root of k is equal to 2a. Okay. Now what is the next target? We already got the critical point. Okay. Now we have to see at this stage, when k is equal to 4a square, yeah, root k is root 2a. What is the sign of the second derivative? What is the sign of the second derivative? So let us check the second derivative sign. Okay. What is the sign of the second derivative at this critical point? Second derivative is equal to, substitute in the second derivative, k by 2 k by 2 and in bracket k minus 12a square. Okay, k minus 12a square. So 12a square. That means 3 into 4a square, no? 12 square means actually 3 into 4 square. So 4 square is k. Anyway, you can substitute. Or if you want, we can put k is equal to 4 square also. That anyway you can do. Okay. So very clearly, k minus 3k, yeah, minus 2k. So ultimately, this value is negative only. Okay. Anyway, you substitute. K is 4 square, you can substitute, or 4 square equal to k. Anyway, the second derivative is negative. Second derivative is negative. So that means what is the conclusion? Z. Z stands for a square. Okay, the square of area is maximum. Is maximum. When it is maximum? When it is maximum? At this point. Okay, this is the critical point. Either you can write k is 4a square, or root k is equal to 2a. Okay, I think I have done a mistake in the while writing the z actually. Okay, actually there is a k inside the bracket, outside the bracket. Okay, so that k also should be taken. Is it correct or not? K by 4 into s square by 4 into k minus 2a. Okay, so is k by 4 into, correct? Okay, k square. K square minus 2a raised to 4. Okay, okay.
Hello, sir.
Yes.
There is some mistake. 2a into bracket k minus a square. There must
That
be.
is why I'm searching actually, sir.
There is 2a cube, sir.
Where?
Still. There is, sir. A by.
Correct. S square into 2a, no?
Ah,
Yes, yes. That's why I'm searching. Actually, s square into 2a. That is 2a cube. Correct. So derivative also will be changed, okay? Accordingly, slight modification will come. 2a cube actually. That means it is 6 s square, isn't it? Now it is okay now? So everywhere you make that correction, okay? So if I take 2 outside, sorry, 2 outside, then k by 2 into ka minus 3 s square. Then second derivative will be k by 2 into k minus k minus 6a. So dz by dA equal to 0 means ka minus 3s square is equal to 0. So everywhere some correction, we have to do some correction actually. So k minus 3a equal to 0. Okay. Therefore, k is equal to 3a. Remaining is okay. Therefore, k is equal to 3a. Since a not equal to 0, k is equal to 3a. Okay. Now, when second derivative, when k is equal to 3a, the second derivative also, I think I have changed it. Okay. So k by 2 into k minus 6a. K by 2 into k minus 6a. The 6a means that is 2 into 3a, 2k. Okay. So you change you make the correction, okay? Some mistake was there in the first derivative. So please make it corrected. So anyway, the second derivative is negative. That means the value is minimum. When it is minimum, the critical point is k is equal to 3a. Now what is k actually? What is k? K is equal to h plus k. Okay. K is equal to h plus a. So that means you will get h is equal to 2a. H is equal to 2a. Now you remember our figure, the right angle triangle, hypotenuse at h, and other side is a, and angle between h and a we have to find out. Okay, angle between h and a we have to find out. So what we can write from here actually, if h is equal to a, what is a by h? A by h is equal to 1 by 2. No? We got h is equal to a. So that means a by h is equal to 1 by 2. Now that is equal to a by h stands for a by h for this angle theta. What is mean by a by h? Adjacent side by hypotenuse. Okay, adjacent side by hypotenuse means that is the cos of the angle theta, cos theta. Okay, so cos theta is 1 by 2, and cos theta is equal to 1 by 2 means what is the value of theta? Theta is equal to 60 degree, yeah, pi by 3. Okay. I think it is clear, na? Okay, actually there was a mistake in the beginning, so please correct it, okay? And thank you for the correction. Somebody has pointed out that correction actually. Now we'll take one more problem and we will wind up this application of derivatives, okay? This also can be asked as a case study problem. I think last year in some of the sample paper or somewhere, this question was there actually. Based on this, okay, there is a playground which is in the shape of ellipse, okay. So inside that ellipse, we want to construct a rectangular playground in that way. So what is the maximum area of that playground? What is the maximum area of that playground which can be constructed inside that ellipse whose vertices are on the ellipse? So the question is, find the area of the greatest rectangle that can be inscribed in this ellipse. Area of the greatest rectangle that can be inscribed on this ellipse. Okay, this is a very standard ellipse, you know. This is the equation of the ellipse. Okay, so this is our ellipse. A and B are the semi-major axis and semi-minor axis respectively. So we have to write, we have to inscribe a rectangle inside this ellipse. We have to inscribe a rectangle inside this ellipse like this, okay? So what is the maximum area of this ellipse? What is the maximum area which can be inscribed in this ellipse? That's the question. Okay, we can vary the length and breadth and we can inscribe different types of rectangles, you know. Okay, so when we will get the maximum area, what should be the length and breadth of that particular rectangle? So let the rectangle be ABCD. You can put give some name, and length can be taken as some 2K, 2H. Okay. Why I am taking 2H means so that I can take HH on the left and right part. Okay. It is symmetrical with X and Y axis actually. So I will take the length of the rectangle as 2H. And similarly, the breadth of the rectangle as 2K. Okay. Let AB is equal to H be the length and CD, sorry, BC equal to K be the breadth. of the inscribed rectangle. Okay, inscribed rectangle. Why I have taken length 2h, length 2k, sorry, 2h and breadth 2k? You can very easily understand it. So that this distance will be h, okay, and this distance will be k. So that this coordinate will be h comma k. The coordinate of B will be h comma k. So h comma k is a point on this ellipse. Okay, so it must satisfy the equation of the ellipse. Remember. Now the area, we have to maximize the area of this ellipse. So area means length into breadth. Area of the rectangle means length into breadth. So area is equal to A is equal to length means 2h, breadth means 2k. That means area is equal to 4 times hk. Area is equal to 4 times hk. Area of the rectangle is 4 times hk. Again, we have to differentiate and find the critical point, etc. So before that, we have to convert in one variable, h and k. There are two variables, h and k. So we have to convert in one variable. For that, what we have to do, this hk is a point on the ellipse, okay? hk is a point on the ellipse. That means it must satisfy the equation of the ellipse. What is the equation of the given ellipse? X square by s square plus y square by b square equal to 1. Okay. So from here, either h or k we can take. So what is k square by b square? K square by b square means 1 minus h square by s square. 1 minus h square by s square. That means k square is equal to b square by s square into s square minus h square. Okay. The right side is actually s square minus h square by s square. So if you multiply b square, the k square will be equal to. Okay. So I will write k square only. And here also, to get to k square, I will take the square. Otherwise, we have to write the root. To avoid the root problem, I will take the square of this area. And otherwise, we have to write k is equal to b by a into root of s square minus h square. To avoid that root term, better to take the square. So s square is equal to 16 into h square k square. Okay. And that's equal to 16 h square into k square. K square is what? B square by s square into a square minus h square. Okay. Further, this can be simplified. Okay. So 16, all the constant you can write together in the beginning. So 16 b square by s square is a constant actually. Okay. Into remaining h square, you can take multiply inside the bracket. So s square h square minus h raised to 4. 16 b square by s square into s square h square minus h raised to 4. So this is our function now. This is a function in one variable. Okay. What is the variable here? H is the variable actually. A is a constant, B is a constant, 16 is a constant. So H is the variable. Because remember, the rectangle what we have inscribed is not a fixed rectangle. Okay. It is a variable rectangle actually. The length and breadth can be varied. Now the next step, as usual, we have to find the first derivative, second derivative, etc. Okay. So before doing the derivative, let us name it as some z. Let z is equal to s square. So that we can write the terms, okay, dz by dh. Differentiate with respect to h because h is a variable, okay, h is a variable. So dz by dh is equal to 16 b square by s square into derivative of s square h square, that is s square into 2h minus 4h cube, 4h cube. Is it correct? Is it okay now? Okay. So let us write the second derivative also, same time, okay? So what is the second derivative? D square z by dh square is equal to 16b square divided by s square into 2s square. 2s square, derivative of h means 1 with respect to h. Derivative of h with respect to h means 1. So 2s square minus 12h square. 12h square. Okay. Always we need the first derivative and also the second derivative. Okay, let us find the critical point now. Okay. So equate dz by dh equal to 0. dz by dh equal to 0 implies equation 1, that is dz by dh, okay? From that expression, if you equate that expression to 0, what you will get? 16b square by s square is a constant, okay? So that is not going to affect. So the bracket term, what is the term inside the bracket? 2s square h minus 4h cube must be equal to 0. The bracket term, that is 2s square h minus 4h cube is equal to 0. So from here, you can take a 2 common and h common. So inside the bracket, we will get s square minus 2 h square is equal to 0. So which implies very clearly h cannot be 0. So that means you will get s square minus 2h square equals 0. That is s square is equal to 2h square. Okay. S square is equal to 2h square. Yeah, a is equal to root 2h. Both are equivalent only. Okay, that is our critical point. Now we have to confirm whether area is maximum or minimum at this critical point. Okay, so for that we have to substitute this value in the second derivative. Let us see what is the sign of the second derivative. Therefore, d square z by dh square, d square z by dh square is equal to 16b square by s square into in place of 2h square, the value is s square. Okay, so that means 2s square minus 12h square. 12h square means 6 into 2h square. 6 into 2h square means 6s square. Any value you can substitute, okay? In place of s square also we can substitute 2h square. In place of h square also we can replace by s square. So very clearly, this value is negative. 2s square minus 6s square means that is negative. So it is confirmed that z stands for s square, okay, is maximum. Maximum. When s square is maximum? At this point, okay. When A square is equal to 2h square. Or A is equal to root 2h. Or h is equal to a by root 2, like that we can write. Okay. All are equivalent only. So a square is maximum at this point. A square is equal to h square. Yeah. A is equal to root 2h. Okay. Whenever a square is maximum means A is also maximum. That is very clear. Okay. Therefore, A is also maximum at this point only. So maximum area we have to find out. Okay. So what is the area at this time? So we have already written the area in the beginning. So take that area. What we have written is 4 into h into k. Okay. 4 into h into k. So we need to substitute the values of h and k. So h is already we got from from that k also we will get. Otherwise we can substitute in the second part also anywhere. Okay. So s square we have got now so h, the value of h we have got already. We need the value of k. For that you can apply which one? We know the relation between h and k, no? This is a relation. Okay. So k square is equal to b square by s square into s square minus h square. So h value is already ready. So from here you will get the value of k square. So that can be done by yourself. Okay. So after getting h, you find the value of k, and both value you can substitute in the area. So that will give the maximum area. Okay. Okay. Somebody has given the answer actually. The maximum area is 2AB. Okay. K is equal to 3A. Some correction already I could see. That mistake was noted by some people already. Okay. Anyway, thank you. We have already corrected it. No? Okay. Okay. With these problems, I would like to move on to the next topic. Okay. Integration, integrals. You know, integral is the reverse process of differentiation. Okay. Integration and differentiation both are inverse process of each other. And the integral calculus, the calculus has two branches: differential calculus and the integral calculus. Differentiation, everything we have already done. Now the second part of the calculus is the integral calculus. And integral calculus has two branches, means two parts actually. One is the definite integral part, and the other is the indefinite integral. Okay. So first we are going to study the indefinite integral. Okay. When a function is given, how to get the integral of that function. I think all of you must have studied integrals in your school actually. Okay, so just we will go through some problems. Okay, we will discuss some problems. That's the main target. Otherwise, we cannot discuss everything within this limited time actually. You know, you also knows. So I think there is no need of taking the basic examples. Everybody knows the idea of integral, isn't it? Otherwise, you give me some suggestion in the chat box. What you require actually, which area is to be discussed. Okay, I will see the chat box. Okay, you make a suggestion in the chat box. Anyway, we know that the derivative of sin x is equal to cos x. Derivative of sin x, d by dx of sin x is equal to cos x. Then what we say, cos x is the antiderivative of sin x. Okay, yeah, cos x is the an integral of sin x. Antiderivative, yeah, integral. Okay. And not only derivative of sin x is cos x, we also know if you add any constant to this sin x, if I add sin x plus 10, the derivative of sin x plus 10 is also equal to cos x. So in that way, if I say the integral of cos x can be also sin x plus 10, isn't it? If I put sin x plus 100, derivative of sin x plus 100, that is also cos x. That means if I add any constant to this function, there will not be any changes. No? So d by dx of, generally what we can say, d by dx of sin x plus a constant. Any constant. It can be 100, it can be 10, it can be minus 2, it can be 1 or 2. Sin x plus a constant, sin x plus c, that is equal to cos x. Okay. So in the reverse way, what we say, the integral of cos x, and the symbol, everything you know. So integral of cos x dx. This is the way of writing the integral. Integral of cos x dx, and that is equal to sin x plus c. Isn't it? Integral of cos x dx equal to sin x plus c. And c is called the constant of integration. Okay, c stands for any constant. So when we are integrating indefinite integral, when we are integrating, we are getting a family of functions actually. Okay, sin x plus c representing a group of functions, a family of functions. Okay, it contains sin x plus 1, sin x plus 2, sin x plus 3, like that. Okay. It is a family of functions actually. In indefinite integral, after integrating, you are getting a family of a collection of functions actually. Sin x plus c stands for a group of functions. Okay, sin x plus 1, sin x plus 2, sin x plus 3, like that. So generally we put the constant as c. We don't know what is the exact constant. If some particular conditions are given, we can identify, you can find that constant also. Okay, if some additional information is given. So this is the basic idea of integral actually. Okay. For any function, whatever the derivative we know, we can apply the reverse way. So first thing, you must be thorough with all the basic formula. Then only we can do the integration of any functions actually. Okay. For any method, we need to know the basic formula, the basic integrals. Okay. So basic integrals from where we will get? We will get from differentiation only. Okay, from differentiation only. Okay, let me check the chat box. Some comments or some suggestion may be there. Okay, trigonometry. Good morning, sir. Please take some hot problems on relations and functions. Okay. JNV, Abhi to me. What is that? Some point 3. What is that? I don't know. 0.3 is written there. Okay, Lakshmi Narsi. Good morning, sir. Please take some hot problems on relations and functions. Thank you. Okay. If time is there, I will take 7.3 exercise. 7.3 exercise. Means textbook exercise 7.3. Actually, I am asking what you require in integration. But you people have asking trigonometry, course problems from relations and functions, etc. Okay. If time is there, we will see that also. Okay. Okay. Anyway, today we will discuss integration. Tomorrow, I may do some problems from the relation functions and inverse trigonometry. Okay. Properties of definite integrals. Definite integrals. Okay. I think the integration, all the methods you might have studied in your school, isn't it? So I no need to explain each and every method actually. And time is also not there for that in this limited time. So I have some problems with me. So I will discuss those problems. Okay. I hope that integration is completed in your school actually already. So there is no problem, isn't it? Just to have a revision actually. Okay. Let's have a revision. And in between, if any method is to be revised, we can do that also. Okay. I have some problems with me, some collection of problems from integration. So I think it is visible now. So you take the first question. I think it is very clear. Integral 0 to pi by 2 cos x divided by 1 plus sin x into 2 plus sin x. In integration, you must thorough with all the basic integral formula. That's the one thing. Okay. All the formula, you must be thorough. Then all the methods also. So once you see a problem from integration, you must identify first which method can be applied here. Sometimes substitution method, then after substitution also we have to convert to some other method like that. Okay, sometimes partial fraction. Okay, so see the first question. Cos x upon 1 plus sin x into 2 plus sin x. Integral from 0 to pi by 2. I think most of you may be able to do this problem, isn't it? Is it possible? So what is the method? Let me see your chat box. Okay. You just tell me the idea. Okay, what should be done here? Yes, sin x equal to t, or 1 plus sin x equal to t. One suggestion, substitution method. Okay, put 1 plus sin x equal to t. 1 plus sin x equal to t. Yes. Any other? Substitution by partial fraction. Then partial fraction. Okay, good. Using property. Somebody is saying using property. Okay. So many of you have the idea. So the method is you can substitute either 1 plus sin x equal to t or directly only sin x equal to t. Both will do. Okay, it doesn't matter. If you put sin x equal to t, derivative of cos x is in the numerator actually. You know? So cos x dx will be dt. So this integral will be reduced to dt divided by 1 plus t into 2 plus t. If I substitute sin x equal to t, okay. Putting sin x equal to t, so very clearly cos x dx will be equal to dt. And limit also we have to change, okay. The lower limit is 0, x equal to 0. X equal to 0 implies t equals sin 0, that is 0. And x equal to pi by 2, upper limit is pi by 2. That implies t is equal to sin pi by 2, that is 1. So ultimately, this integral reduces to integral from 0 to 1 dt by 1 plus t into 2 plus t. Now apply the partial fraction. Okay. Now apply the partial fraction. I think here also the partial fraction, you no need to follow the whole process. Okay. Directly, very easily, we can write the partial fraction. The first term will be 1 by 1 plus t minus the second term will be 1 by 2 plus t. Directly we can write. Have a check. Just cross multiply and see whether it is true or not. Okay. Anyway, we have to express in partial fraction. Okay. There is no rule that you must follow everything. There is no need actually. Sometimes it may be possible to write the fractions directly. So you can easily write it. Okay. So 1 by 1 plus t minus 1 by 2 plus t. So each integral is known to you. 1 by 1 plus t means log 1 plus t, log mod 1 plus t. And 1 by 2 plus t means log mod 2 plus t. Okay. So both are integrable, standard integrals actually. Formula you have to apply and substitute the limit. Clear? Let me take another problem. Second problem. I think this is the problem which asked in the recent exam, term 1 examination. Maybe some similar problem. Yeah, exactly this may be. One problem was there almost in this way in the term 1 examination, isn't it? So what is the method here? Here also we have to do a substitution. What is the substitution needed here? E raised to x is equal to t. put e raised to x equal to t. Therefore, derivative of e raised to x, you know, e raised to x, derivative of e raised to x is e raised to x only. So dt by dx equal to e raised to x, yeah, e raised to x dx equal to dt. Therefore, the given integral reduces to integral dt divided by root of 5 minus 4 e raised to t. Sorry, 4t. E raised to x is taken as t. Okay. So 4t minus e raised to 2x stands for e raised to x the whole square. Okay. E power 2x means the square of e raised to x. That means t square. Now this is 1 by root of a quadratic form. You know? Inside the root, there is a quadratic polynomial, quadratic expression. Okay. So we know the method actually. Whenever there's a quadratic form, 1 by a quadratic, 1 by a root quadratic, we have to convert into either x square minus s square form, yeah, s square minus x square form, yeah, s square plus x square form by applying the completing the method. I mean, so method of completing the square. Okay, so it's easily we can do here 5 minus all the minus I will take outside after 5. Okay, so t square plus 40. 5 minus of t square plus 40. Then we can easily identify which term should be added in order to make it as a perfect square. Which term should be added to t square plus 40 in order to make it a perfect square. So what is the method for that? Take the coefficient of t, that is 4. Then take the half of that, that is 2. Then square it. That means 4. Okay. So we have to add 4 and subtract also 4 to balance it. No? So inside the bracket, we are adding and subtracting 4. So that won't make any change actually. Okay. There is no change in the whole expression. So that is equal to integral of dt upon root of 5 minus up to here t square plus 40 plus 4 means that is t plus 2 the whole square, t plus 2 the whole square. Okay, what is t plus 2 whole square? T square plus 40 plus 4 minus 4. Everything is inside the bracket. Okay, t plus 2 whole square minus 4. So everything is inside the bracket minus of. And that is equal to integral of dt upon root of 5 minus t plus 2 whole square plus 4. If you remove the bracket, minus of minus 4 becomes plus 4. And that is equal to integral dt divided by root of 5 plus 4, that is 9. 9 minus of t plus 2 the whole square. So that is equal to integral of dt divided by root of 9 means 3 square. So 3 square minus of t plus 2 the whole square. Now this is a standard integral. Now you should know the formula, the basic formula. Then only you will be able to write the answer. So what is the corresponding formula? What is the formula we have to apply here? Integral dx divided by 1 by root of a square minus x square. Okay. If you know this formula, so this integral is exactly of this form. So what is the formula? I think all of you know this formula. 1 by root of s square minus x square is what? Sine inverse x by a. Sine inverse of x by a. Isn't it? Okay. So apply the formula. So this is equal to sine inverse of a plus 2 divided by 3. Sine inverse x by a plus c. Again, replace t. Okay, what is t? You know, t is what? E raised to x, no? E raised to x. Then this one. I think this problem, yeah, similar problem was there in the term 1 examination. Almost same or exactly the same. Integral of 2x upon x square plus 2 into x square plus 3 dx. So what is the method actually? Very easily, everybody can identify the method. No? In integration, the important thing is you have to identify the correct method after uh, seeing the question. Once you know the method, everything will be mechanical. If you know the basic formula, we can do it very easily. Okay, so correct method you have to identify what should be done here. Substitution, after substitution, what to do, like that. I hope that all of you know the method na, for this question. You can put in chat box if you know. X square equal to t. Okay. Ganesh. X square equal to t. X square plus 2 equal to t. X square plus 1 equal to t. So many opinions are there. And partial fractions. Okay. And partial fractions. Okay. Good. Okay. So many comments are coming. Correct. X square can be taken as t, or x square plus 2 can be taken as t. Doesn't matter. Okay. Better to take x square equal to t. Then 2x dx will be dt. So this integral reduces to dt divided by t plus 2 into t plus 3. T plus 2 into t plus 3. So easily that can be converted into partial fraction directly. Okay. The first term will be 1 by t plus 2. Other term will be minus 1 by t plus 3. Okay. Zero to pi by 2. Root of 1 plus tan x. 0 to pi by 2 root of 1 plus tan x dx. Integral from 0 to pi by 2 root of 1 plus tan x dx. Here also you may be knowing, many of you may be knowing the method. Anyway, what is the method actually? Tan x we have to write as sin x by cos x, okay? The tan x you replace. What is tan x? Sin x by cos x. Root of tan x means root of sin x divided by root of cos x. And that is equal to 0 to pi by 2. Simplify the denominator, cross multiplying, etc. Then root of cos x will go in the numerator. Root of cos x all divided by root of cos x plus root of sin x dx. Okay, now I think you know the method, no? This is a very standard question actually. In textbook also same question may be there actually. So apply the property. No? Apply the property. You take this integral as I after this stage. Let this integral as I. Put it as some equation 1. The original integral, the given integral, take it as I. Then we have a property, After applying the property, the same integral we can write using the property. Wherever x is there, we can write a minus x. Limit a, if it is a. Here the limit is pi by 2. Okay. So we have the property 0 to a. Integral from 0 to a f of x dx is same as integral from 0 to a f of a minus x dx. It's a very important property. Usually questions are asking from this area using this property. So 0 to a f of x dx is same as 0 to a f of a minus x dx. That means wherever x is there in the function, we can replace by a minus x if where the limit is a, okay, 0 to a. So here the limit is 0 to pi by 2. That means wherever x is there in the function, we can write pi by 2 minus x. Okay. Everywhere in the function, you replace x as pi by 2 minus x. That is the property says, okay? The property says like that. So that is equal to 0 to pi by 2. The numerator becomes cos pi by 2 minus x means sin x. So root of sin x divided by denominator. In place of cos, it is sin. And in place of sin, it will be cos. So put it as equation 2. The same integral, okay? Original integral, after applying the property, the same integral I is equal to root of sin x divided by root of sin x plus cos x. Now you compare the original where we have started I equation 1, you see the denominator is same root of cos x plus sin x. In the second, after applying the property, the second equation, what we have got just now, there also denominator is same. So that means we can add the numerators, okay? Even the answer also, you can by heart it, If I add the two integrals, the 2i, I plus I is 2i, and denominators are same. So we can add the numerator. So numerator and denominator become same. So you will get 1 after adding. Numerator and denominators becoming same. So 1 dx. Integral of 1 dx is max x And if you substitute limit as pi by 2, so pi by 2 minus 0. So 2i is pi by 2, so I is equal to pi by 4. Okay. The fifth problem also same property, means not the same property, but almost same property. Property of the definite integrals. Okay. Let's take the eighth problem. Integral x square upon x minus 1 into x minus 2. Integral of x square upon x minus 1 into x minus 2. So what is the method we have to apply? Power is same. So we have to divide the numerator and denominator. JNV Karekal. Okay, good. Divide. Okay. Partial fraction. Partial fraction. Divide numerator and denominator. Okay, some comments are coming. Very nice. Any other comments? Any other suggestion? Divide, partial fraction, all these are coming. Okay. Okay. So what is the method actually? Sometimes we may commit mistake, na? Some people directly go for the partial fraction, but that is wrong. Okay. When we can apply partial fraction, when we can apply the partial fraction, when the given rational function is a proper fraction. Proper fraction means the degree of the numerator must be less than the degree of the denominator. Then only we can go for the partial fraction. Remember, okay? Here the degree is same. Numerator and denominator both are quadratic of second degree actually. So we cannot go for directly partial fraction. Remember. So first we have to divide. Whenever the degree of the numerator is equal, yeah, more than that of the denominator, degree of the denominator, we have to go for division first. Okay, make it a proper fraction. So that is the first step. So denominator we have to multiply and remove as a quadratic. Okay, then divide. So first to go for division. So x square divided by denominator is x minus 1 into x minus 2. If I multiply, that is x square minus 3x plus 2. Then divide x square in x square one time. 1 into x square, okay, minus 3x plus 2. We can also do in a shorter way also. So the remainder will be 3x minus 2. Clear? Degrees are same. So we have to go for division first. Divide x square by the denominator. Then after that, you will get the quotient as 1 and remainder as 3x minus 2. So express. Therefore, the given expression, rational function, x squared divided by x minus 1 into x minus 3, x minus 2, okay, sorry, x minus 2, isn't it? Is equal to, what is the quotient? That is 1 plus remainder 3x minus 2 divided by the denominator x minus 1 into x minus 2. Okay. Now, the second term, second expression, you can very easily, we can see that the degree of the numerator is less than degree of the denominator. Then you can go for partial fraction. Okay. The second part, you can go for the partial fraction. Actually, there is one more method also, you know. Anyway, one of the method you can apply. Okay. So consider, yeah, let only that proper fraction part we have to convert. Okay. So 3x minus 2 divided by x minus 1 into x minus 2. So what is the partial fraction corresponding to this? First partial fraction, first term must be a by x minus 1 plus second term will be b by x minus 2. b by x minus 2. Okay, the denominator contains two linear factors. So correspondingly, we have some linear terms here also. Now we have to find a and b. You know the method. For that, you compare the numerator both sides. Okay, so make the denominator same in both sides. So right side just cross multiply. So a into x minus 2 plus b into x minus 1 all divided by x minus 1 into x minus 2. So if you just compare the numerator only, the numerator is 3x minus 2 here. So 3x minus 2 equal to a into x minus 2 plus b into x minus 1. Okay. So we have to find a and b. We have to find a and b. That is the next target. And how we used to find a and b? There are two methods actually. One is just compare the coefficients of similar terms on both sides. Okay. Otherwise, or better, you can put some values for x. We can put any value for x both sides at the same time. And better to put the value in such a way that this term should be 0. So if you want to find a means, we have to make the second term 0. Okay. So if you make second term 0, you will get easily a. So you can put some values for x so that the second term 0. So very clearly you can put x equal 1. If I put x equal 1, b into x minus 1 becomes 0. Okay. So I put x equal 1. X equal 1. That implies everywhere we have to substitute. Okay, x equal 1. So 3 into x minus 2 means 3 into 1. 3 minus 2 is 1. Left side is 1 actually. 3 minus 2 is 1. And right side, a into 1 minus 2. 1 minus 2 is negative 1 means minus a. And other part is 0. No need to write also. So directly we will get a. Okay. So a is equal to negative 1. A is equal to negative 1. Then we will find b. Go for b. To get b, what to do? The same technique. We have to make the first term, the term containing a, to 0. Okay, we have to make it 0. So for that, what can be substituted for x? Very clearly, that is 2 only. Okay, x equal to 2. The same expression. Okay, in the above expression, the same expression, put x equal to 2. X equal to 2 gives. Left side is 3x minus 2. So 3 into 2, 6. 6 minus 2, 4. 3 into 2, 6. 6 minus 2, 4. And that's equal to right side. The first term will be 0. And second term is b into 2 minus 1. That is b only. So now we have the value of b also. Okay, b is equal to 4. I think the remaining we can do very easily. Substitute a and b. That means our given expression, okay, x square divided by x minus 1 into x minus 2 is equal to 1 plus, isn't it? 1 plus 3x minus 2 divided by x minus 1 into x minus 2. We have converted into partial fractions. A divided by x minus 1. What is a here? Minus 1. So minus 1 divided by x minus 1 plus 4 divided by x minus 2. Clear? So now easily indicate this can be integrated very easily. Okay. I think the time is already 8:37. I took more time actually, you know. Okay. I am Ujjwal. Do some hard questions, sir. Okay. Okay, children. So we will wind up here. Okay. So we will meet again in the afternoon, 2:30 p.m. Okay.